All right, here we go again, part 2. We were looking at choices. We're on C. Is 3 groups of 3 an actual representation of what we drew up here? Clearly we can see we have 6 groups of 3 or 3 groups of 6, but not 3 groups of 3. So we're going to eliminate that choice. That leaves us with repeated addition as one of our choices. So I can either say that I have 6 plus 6 plus 6, or this group of 3's here. So we're going to look at those. Here I see that I have 6 things, I have 6 things, and I have 6 things. So I do have 6 plus 6 plus 6. I'm going to put a little check mark by that. But I'm going to go ahead and double check my other one. This one says 3 plus 3 plus 3 plus 3 plus 3. When I look at this, I don't have the 6th group of 3 things. So this answer is not correct either. The 2 choices were a flip-flop fact or commutative property for multiplication and a repeated addition that represent this picture. Finally, they're going to have us answer the question, going back to the question, how many photos does Pablo put in his photo album altogether? We found out he can put 18 total photos. Pablo puts 18 photos in his photo album altogether. Looking at number 4, is each expression equal to 8 groups of 5? So one of the things that we've been doing for this is actually to see if students understand how they can use the distributive property or breaking a larger multiplication equation into smaller parts to make it easier to solve. We have taught students to use an array and break it apart. So we're going to go ahead and draw 8 rows. 5, 6, 7, 8. And we're going to put 5 things in each row, 8 rows of 5. So I have 8 rows of 5 in this array. Then what we can do is we can look at the choices they've given us and determine if I'm able to break this entire array into these smaller pieces. So the first choice says I have 3 rows of 5. Okay, if I look and I highlight 1, 2, 3 rows of 5. I can even write that out to the side there. The highlighted portion represents a smaller array of 3 rows of 5. Then I look at what is remaining. The remaining portion is 1, 2, 3, 4, 5 rows of 5 things each. In order to have 8 rows of 5, I would have to put these 2 parts back together. And one of the ways we've been doing that this week is we have been using a number bond and unit form. So this multiplication represents 8 5s, or 8 times 5, and I've broken it into parts here. I broke it into 3 5s, which is 3 times 5, and I've also broken it into 5 5s, or 5 times 5. Okay, when I do that, if I put these 2 parts back together, they will equal the whole. So yes, this equation does equal 8 groups of 5. Looking at the next one, if I did 2 groups of 5 and 4 groups of 5, is that going to be the same as 8 fives? I cannot make 8 rows if I only have 2 rows and 4 rows. This would represent 6 rows of 5 if I were to put it back together. Okay, when I look at the next choice, 4 rows of 5, 4 rows of 5. If I went ahead and highlighted one more row to put it in this group, my group in yellow has become 4 rows of 5, and my pink group has become 4 rows of 5. If I put 4 rows and 4 rows back together, it will give me 8 rows of 5. So this is also correct. This one was not, so we're going to put no. Looking at my last choice, we talk a lot in class about this. This is just someone who is trying to trick us on a test. We can put 5 rows and 3 rows back together to make 8 rows. They do have 5 things in each row, just like this original equation. Unfortunately, when I look at this symbol in the middle, it is not addition or putting those 2 parts back together. In fact, that would be representing 25 times 15, which would be way more than 8 groups of 5. So this does not represent that picture. I highly recommend students drawing an array and then literally just breaking it into its parts, or doing a number bond and seeing if it makes sense. Number 5, Eva draws this array to represent 3 groups of 4. We have 3 rows. There are 4 things on each row. She says the array also represents 4 groups of 3. Again, if I make groups this way, 1, 2, 3, 4, I do have 4 groups of 3 as well. Is Eva correct? Explain your thinking. We would want to say yes, because groups can be rows and groups can be columns. It's just explaining that commutative property that both are going to equal 12. Number 6, fill in the blanks to find 8 times 4 and use the array to help. Okay, again, this is a break apart and distribute strategy, or the distributive property. We have 8 columns that each have 4 things each. I'm going to go ahead and do a few things here. I'm going to say I have 8 4s as my whole amount, or 8 times 4. And I'm going to see what I can break it into. Here is the original amount that I'm trying to solve, 8 times 4. What they did not include, and I would encourage your child to go ahead and write, is I'm still trying to solve 8 times 4. I'm still trying to solve 8 times 4. The first thing they do is they're going to break apart 8 rows of 4 into 5 4s, or 5 times 4. So I'm going to come and I'm going to break apart this picture. 1 column, 2 columns, 3 columns, 4 columns, 5 groups of 4. There are 4 things in each of those, and there are 5 columns. This part represents what this little piece represents. This represents that piece as well. I have 8 total groups. I have broken it into smaller group size. So I have 5 groups, and I would need 3 more groups in order to make the 8 total. Here I can see that 1, 2, 3 groups of 4, or 3 times 4. That is the piece that I'm missing here. 3 times 4. Then we look underneath that. I still need to solve how much is 8 times 4. 5 groups of 4 was 5, 10, 15, 20, and that is this amount that they've already written in. One of the biggest mistakes I see is students just misunderstanding the blanks, and they might put the 20 here. So just paying attention to what they've already filled in for them. Then looking at 3 columns of 4 and counting that amount, 3, 6, 9, 12. The final step would be to put those parts back together to make 8 groups of 4. 20 and 10 more makes 30. 0 and 2 makes 2, 32. 8 groups of 4 is the same as having 32. Number 7. Which situations can be represented by 20 divided by 5? I would encourage students to remind themselves of the things we have in division and multiplication. So in division, I have a total, I have groups, and I have how many are in each group. I always say you have to get these things in order to divide. You have to get these things in order to multiply. Okay? Looking, I need 2 choices. The total of 20 shells and 5 shells. I do see the word total there, but I don't have 20 groups. I don't have 20 in each group. I don't have 5 groups. I don't have 5 in each group. When I read this as a whole, I realize that it's asking me to put those 2 amounts together. 20 plus 5. Not the answer I'm looking for. The difference of 20 coins and 5 coins. This is a word that hopefully they're familiar with from 1st and 2nd grade. Difference represents subtraction, not the operation that I'm looking for. The total, it's one of my key words, number of tickets when 5 children each have 20 tickets. Okay. I'm thinking about that. Division always starts with the total. If I give each student 20 tickets, there's going to be way more than 20 tickets total. So this again is one of those trick questions, but I could just draw that out. If I had 5 kids, and I said, you get 20, you get 20, you get 20, 20, and 20. I can see, without even adding it up, that that's going to be way more than my total. Can't be my answer. The number of groups, there's one of my important words. When 20 toys are put into groups of 5, remembering what the multiplication actually represents, groups of, and then how many is in each group. That will make your total. Okay? Yes. The number of blocks in each group when 5 children share 20 blocks equally. So again, I've got 20 total blocks, and I'm sharing them between 5 children. Yes. All right, finishing up. This is a 2-step story problem, meaning